Our procedure for today has to do with how to evaluate inequalities using a line graph. So for rational inequalities, get 0 on the right side of the inequality. Add fractions. Then factor. Mark hash marks at zeros and vertical asymptote locations. Determine the sign for each interval by checking one point in each interval. Shade the appropriate intervals and state the solution. I suggest that you stop the video now and copy these steps down, and then we'll actually apply the steps to the set of problems below. For our first inequality, we have the product of the linear expression x plus 3 times the square of the expression x minus 1. So we'll draw our number line. What value of x takes this to 0? Well, negative 3 does. There's a hash mark. 1 takes that factor to 0. There's a hash mark. There's no equal sign associated with the inequality, so we'll put an open circle at each of these. Notice, an open circle corresponds to less than or greater than, parentheses, open circle, corresponding to equal signs in association with an inequality. We have brackets for interval notation and a closed circle. So now, next thing to do, check the value of one point in each interval. If one point in an interval gives a sign, then every point in that interval will give that sign. So let's take a point like in this interval, which goes to negative infinity, something like negative 100. Installing negative 100 in for x, and this will be negative. This factor, because it's squared, will be positive. The product of a positive and negative is negative. On the other hand, let's check out a point in this interval. How about 0? If we replace x with 0, we have 3 times a positive value, and positive times a positive is positive. Now let's check out a point in this interval. And how about 10? Replacing x with 10, this will be positive. This will be positive because it's squared. So a positive times a positive is positive. So now we'll shade the regions that are positive because we're talking greater than 0. And in interval notation now, in set builder notation, we'll state the solution. And that's going to be x such that negative 3 is less than x, which is less than 1, or x is greater than 1. In interval notation, that will be negative 3 to 1, parentheses, union, 1 to infinity, and notice we've enclosed these with parentheses, these values corresponding to what we have up here. For the inequality x cubed minus 4x squared, which is less than or equal to 0, our first task is to factor. So we can factor an x squared out of each of these terms, and we wind up with 2 factors. So we'll draw our number line. And what value of x takes this to 0? X to 0, well, 0 does. So here we are at 0. What value of x takes this factor to 0? Well, 4 does. Now notice we have an equal sign associated with the inequality, so we'll use a solid dot. And now it's time to check each interval. because if a point in an interval gives you a sign, then every point in that interval will give you the same sign. So let's pick a value less than 0. How about negative 10? Replacing x with negative 10, this will be positive because it's squared. This will be negative. And the product of a pair of unlike signs is negative. Replacing x with a value in this interval, such as 1. This factor will be positive, but this will be negative. Again, we have the product of two unlike signs, so that's negative. And now letting x take on a value greater than 4, such as 10, we'll have the product of two positives, which is positive. Now we have a less than or equal to symbol, so we want all the negative signs, or the regions, intervals, associated with negative signs shaded. Now in set builder notation, the solution is x such that x is less than or equal to 4. In interval notation, that would be that would be negative infinity to 4 bracket. And we're done with that. Well, this time we're dealing with a fraction. So it's already factored. We'll solve it by graphing. That's what we're doing, solving all of these by graphing. And x is the variable. The zeros are at negative 1 and 1, because negative 1 takes that factor to 0, 1 takes that factor to 0. We also have an undefined situation at 0. Now, we'll use a solid dot for the negative 1 and the 1. But we have to use an open circle for the value of x that takes the denominator to 0, because division by 0 is undefined. Now we have 1, 2, 3, 4 intervals. We'll check each interval and sign them appropriately. So what if x is, say, negative 10? This factor will be negative, this factor will be negative, as will this factor, and the product of an odd number of negatives is negative. What if x is, let's see, negative 1/2? This factor will be negative, this factor will be negative, but this will be positive. And so the product of an even number of negatives is positive. Now what if x is 1/2, positive 1/2? This factor will still be negative, these two will both be positive, and we have the product of an odd number of negatives, and that will be negative. And finally, what if x is something like 10? And replacing x with 10, we'll have the product of all positives, which will be positive. Now, we'll shade, let's see, we'll shade less than or equal to. So we'll shade the negatives. And good. In set builder notation, we have the set x such that x is less than or equal to negative 1, or 0 is less than x, which is less than or equal to 1. In interval notation, we have negative infinity to negative 1, bracket on the right, parenthesis on the left, union with 0 to 1, and parenthesis and a bracket, and we're ready to move on.